usually has unit roots, it is a random walk process. Is that correct? Yeah.
Yep.
If this is a random walk process, is it a white noise process, Roxolana?
No, it's not.
Why not? Why not?
Because
Because if it's a white noise process, this whole term will be equal to what? 0. This whole term will not, then xt would be exactly equal to the white noise. You understand?
yeah, okay, that makes sense. So I have a follow-up question.
Okay,
So
but hold on, let me just take a deep breath. Make sure you understand this. Make sure you understand why this is not a white noise process. You understand, right?
yeah, I understand.
Because the white noise process will not include this term. Or if it includes this term, then statistically this term will not exist when you do the tests, statistical tests. Okay, go ahead.
So when we conduct the ADF test for our project, do we have to use k equals 0?
Do we have to use what?
In our code, because I remember you showed us 2 ADF tests. One of them had k equals 0, and the other one didn't have k equals 0.
Well, yes, the k equals 0 is a DF test. Is a Dickey-Fuller without the augmented. When you don't have the k equal to 0, that is the ADF. When k is 0, that is a DF. That's a Dickey-Fuller DF, right? But when there is a, is augmented. And what is the difference between the two? The difference between the two is that the DF restricts us to a white noise process. But the augmented Dickey-Fuller is less restrictive. Again, remember the difference between the box pairs and the Leung box. Leung box has less restrictions. The same way, the difference between the DF and the ADF has fewer restrictions. But again, if you are not sure, run them both. Run the DF and the ADF. You see, I think for the project, I said ADF, yes?
Yeah.
Okay, it's okay. Usually, in this profession, when somebody says ADF, they really mean you can run DF and ADF. That's okay, but it is the command without k equal, when there's no k equal to 0, then that is the ADF. When you say k is 0, that is the DF. The DF is much more restrictive, so it doesn't allow you wiggle room. Okay, so in this time series, financial econometrics, usually when we present major statistical tests, we usually begin with the most restrictive, and then we relax it. We did that for box pairs and the long box. Then when we did the information criteria, I introduced the BIC and the AIC. The AIC is less restrictive than the BIC. So most people do the AIC. The same way for the unit root test, the ADF is much less restrictive than the DF. Okay, that's just
thank
the
you.
story.
So the only reason I asked that question, it's pertaining to the project. My group member and I found that it was a white noise process, but after testing for ADF, we saw that it's not stationary.
Yes.
But does that make sense? Can a white noise process be non-stationary?
It probably, well, that's the result you are having. So I don't like it when students quarrel with the results they are having. That's the result you are having. But in real life, it just means that the data you have is a little more complicated than the synthesized data we normally use in class. Because the data I gave you, I haven't told you where it came from. I will maybe later, after the end of the semester, of the official day of class, I'll tell you where the data come from. But these are complicated series I gave you. Okay.
Okay, so even though we have conflicting results, that you think that should be fine?
I won't even think it's conflicting. It's just that uh, probably probably what you're capturing is the fact that uh, that maybe you need a more stringent white noise tests. Okay.
Okay, sounds good. So
So
we'll leave
no,
it
no,
as is.
just again, just look over your commands. If those are the results you're getting, those are the results you're getting. Don't try. I know you are not doing it. You and your teammate done it. Just don't try to forge anything. Just check your commands. Make sure you haven't made a mistake, and go with the results you're getting. Okay? Because your groups, I gave you complicated time series, even though they are quite short. They are complicated. So just that's again, this project is very long, but it's long because I'm breaking it down into steps for you to do.
Mhm.
It's really, I could have just said, hey guys, look at this, Roxolana, you and your teammate, and each team, look at your data and apply homework 1, 2, and 3 commands. I could have just said that because that's what's going on here. Only at the last line did I give you GARCH, arch. That's all.
Professor, so
Wait,
since
hold on, Danny. Okay, I just want to make this point to everybody. So when I posted this sometime over the weekend, I finished working it. I finished doing it, and I took a break for like 2-3 hours, and I came back. I said, "Oh my goodness!" I mean, I think there are 31 or 32, something like that. I said, these students are going to, just kind of just push me around and all that. But I looked at it again. I said, during your midterm, during the spring break, was it when I began to think about, how to present this to you. And I said, look, the most heartless thing for me to do is to say, hey, Team Roxolana, this is your what am I called? This is your series. Team Wardell, this is your series. Team Sylvie, this is your series. Just apply A, B, C. Apply homework 1, homework 2, homework 3 commands, and just get it done. But no, okay. So I apologize for the many questions, but I am just guiding you through step by step. All you have to do is do step 1 and then do step 2, just carefully. By the time you get to the end, you have covered everything we have done in class, but with a different time series. Okay, Danny, sorry.
so what you're saying is with the DF test, if you have a white noise series test, it's okay to do the DF test because it meets that restrictive criteria, right?
Yes, do both. I always want to see the ADF test. But if you don't want to do only the ADF, do both. Do the DF and the ADF. But the ADF must be, if you must do one, do the ADF that I asked you. Okay, but if you want to do the DF, that's okay.
Because if it meets that criteria, which one would you say supersedes which if they give different conclusions?
I will use ADF.
So go with the ADF conclusion.
Go with the ADF conclusion. You can do both. Many times, both of them will give you a similar result. But again, sometimes they deviate. I will always go with the less restrictive one because it allows you your equation to be more general.
Noted.
Okay, all right.
I also have one more question. So you said the maximum amount of pages we could have is 2. However, there are like 36 questions and we have 4 pages. Is there a
Yes,
way
because
to extend the limit?
yeah, but don't forget the deadline because again, as a professor, I struggle with how much work I give my students. I tend to give work, but towards the end of the semester like this, everybody's busy. Number one, number two, the deadline I gave you is Sunday, right? And I think Tuesday is the end of class, right? Is the last day of class. 2 days after that. So essentially, I have 2 days to grade all this stuff, give you your current course average, so that you remember I had promised that at the end, last day of class, I'll give you your current up to that day, how do you say, grading class before the final exam. Remember I said that, right?
Yep.
And that then after that, you look at your grade. If your grade up to that time is a B and you like a B, you don't want to stress final exam and you don't want to take a chance of making fewer than a B after taking the final exam, then you send me an email, say, Professor, thank you, I'm okay with the B. I do not want to take the final exam. So I have only 2 days to do that.
Oh, yeah, I know. No, I meant like about the pages.
I know. So
Oh.
if I say each of you write 10 pages, I cannot grade 10 pages per team in 2 days. It's absolutely impossible for me. So I want you to be, if you want me to increase the page limit, I'll consider that, Roxolana, and for you, for everybody.
Yeah, thanks. Because there's just so many questions. So if you don't increase it, then we'll have to, I don't even know how we're gonna fit all of our answers.
Okay, so let's negotiate. How many pages do you want?
I mean, we currently have 4. Maybe we could cut it down to 3.
Okay. No,
yeah.
front and back is not 1 page. Front and back is not 1. No. Oh, that's funny. No. Okay. So do you, again, only Roxolana is talking. So I don't want to assume that Roxolana is talking for everybody. So do you want 3 or do you want 4? I would prefer 3 instead of 4. Okay. So going, what do you want? 3 or 4? Going.
I would love 4. I don't know about everyone else.
Isn't with 4 like we have the option to like choose 3 and 4, but if we go with 3, then we can only choose like 3. Max.
Okay, so that's great, Mr. Lin, thank you. So can I use the language maximum of 4? Is that okay?
Yeah, I think that's good. I think that's fair.
Okay, Zeshan, is that okay?
Yeah, that would be bad actually.
Okay, so I am going to, so you can make a note, and later, either tonight or tomorrow, I'll go back into the project and say maximum of 4 pages. Okay, so you can write 2, you can write 3, but definitely not more than 4. Is that okay?
Yeah, thank you.
Okay, all right. So let me make a note of it.
Professor, I have a question.
Give me 1 second. Let me say maximum of 4 pages. Okay, go ahead. Who's that? Who's asking? Sophia?
Yes.
Okay.
I'm not sure if someone asked this already, but if we want to get feedback on our project, do we need to send it to you or to your assistant?
Feedback, you can send it to my assistant and CC me. But again, today, I want to, like half the class, I just want to show a couple of things, one on Excel and one on Arch, okay? Because for the project, the very last question is for you to test for Arch effects. So I want to show you tonight. But after showing that and the Excel, then I will just open it up to the project questions today and Thursday. And before it's due on Sunday, if you guys want me to have an office hour, maybe on a Friday evening, this week, Friday evening for 1 hour or 90 minutes or 2 hours, I'll make myself available, but you guys have to come with questions, okay?
Professor.
Thank you.
Wait, Natalie, I'll join you in a second. Okay, so tonight's class, I'm just going to do 2 things, one on Excel, one on R quickly, and then I will I'll be available to answer questions on the project, okay? But again, it really doesn't make sense for me to be available to answer questions on the project if you and your team member have not done the project, if you're just there to listen to some other person, because those people that you're listening to, they have done it and they have specific questions, like Roxolana is asking me now for her team. But if you haven't done it for your team, then it's not really productive for you, okay? So Sophia, I'm addressing you because you asked the question, but I'm addressing the whole class. So thank you for that question. So tonight I'm going to stay, even if I stay until, in fact, tonight, I'll be happy to stay until 7:30 p.m. For class, for here, to take questions on the project. After doing the Excel and the R, I can stay up to 7:30 tonight and take questions on the project. But even if you have not started the project, but I need for you to think about it before you ask me, then you can ask me leading questions, okay? All right, so that's tonight. And then on Thursday, I'll do the same thing. On Thursday, I have just one thing 2 handwritten pages to introduce to you about other types of arch models. And then immediately after that, it's open for the project. And you can ask me questions until 7:30 on Thursday. And if you want me to have office hour only on the based on the project only, I can have office hour on Friday, either 1 hour or 90 minutes or 2 hours, depending on what we decide on Thursday. Okay, so I have you covered to answer your questions for the project, but you need to come to me, to come to class. You need to come to that session with questions. It is very important that you and your teammate begin to do it. Okay. All right. Who has question? Natalie, quickly.
Professor, if I don't have a teammate,
Why don't you have a teammate?
I sent you an email.
Yes,
because
but I had asked the entire class to send me email sometime, way before Saturday, and I think you sent me the email when? Monday? All right. So let me announce in this class, is there anyone else that does not belong in the team?
She can join our group if she doesn't.
Wait, but you have a group of 2 already.
Yeah, we do.
Yes, but I needed only groups of 2. Okay, so, but if there's no other person without a team, then Natalie, I'm asking, Tobias is welcoming you to their team. So I'll make this exception of a group of 3. And the answer is no to a group of 1, because where's Lily? Is Lily in this class?
Yes, I am.
Yes, Lily, remember you had asked me that question like 2 weeks ago. You remember that?
Yes, I remember.
About if you guys could work individually. And what was my answer 2 weeks ago?
No, you cannot.
And my answer was definitely you cannot. So Natalie, you cannot work by yourself. Tobias, I really thank you. Who is your teammate, Tobias?
Ali.
Alec.
No, not Alec. Ali.
Oh, Ali. Okay, Ali. Okay, I know. Alejandra. Okay.
Yeah, Alejandra, sorry.
Okay. So.
Okay. Thank you, Tobias.
So Natalie, officially, please send an email to the TA because she is keeping track of the groups, and then CC me on it. She and I will keep track, but send it to her. Okay, that you are in a group with Tobias. Okay.
Okay, we'll do it today.
So Tobias, you and Natalie and Alejandra, please exchange emails and get to work.
Okay.
Okay, Tobias, thank you very much. All right. Okay, can I go on with class now? Any other questions, quick questions? All right, good. So let's go on with, let me see what other messages people have. Okay, great, all right. Oh my God, that's funny. I mind small font size. Don't use font size of 2, please. Use normal font size 12. All right. So this is what I want to do tonight, quickly. Okay. I want to go over quickly over my arch models, and because one of the questions I had asked you for the project, the very last one, is to test for arch effects. I want to demonstrate with R how we do it. Okay, it's just one command, but I want to show you the concept behind it coming from Echo 4000. Okay, so I'm going to begin to record right now, if anybody doesn't mind.
This meeting is being recorded.
Okay, so hello everyone. So like I said tonight, I want to begin with discussion of arch models. Okay, everybody, we have seen this from last class. This is the specification of arch models. Again, everybody should have this. If you're seeing it for the first time, please go to Blackboard, you will see it. So usually there's a mean equation, okay? There's a mean equation. That equation could be a simple linear regression, or it could be a simple y equals b1 plus b2 x2, or it could be autoregressive, xt equals to the constant plus phi times xt minus 1 plus phi times xt minus 2, and so on and so forth. So that mean model can be anything. But whatever it is, usually to make our life simple, whether it's simple OLS, or whether it's simple white noise, or whether it's autoregressive, or whether it's moving average, or whether it's ARMA, whatever that mean equation is, what is the typical assumption we make about the white noise error term? Number one, that the error term is white noise. It is typically zero mean white noise, homoscedastic. The error terms, the variance of the error terms, constant through time. That's homoscedastic. But typically in practical model, in practical data, those errors tend not to be homoscedastic. They tend to change. They tend to change according to time. How do they change? They change according to time here. Well, how do they evolve over time? We don't know. So we want to find out. And last week I said to you that there are two families, general families of models that we assume that the variance of the white noise process, that the variance of the error terms, or the variance of the residuals, that there are two classes of models we assume they follow. Does anybody remember what I said? One of them I said was deterministic, and the other one was what? Anyone remember the word I used?
Stochastic.
Stochastic, essentially uncertain. The one that is deterministic doesn't have an error term attached to it. The one that is stochastic has an error term attached to it, just like you all are used to in OLS. There's typically an error term attached to the OLS equation. The deterministic one we generally tend to refer to as the family of autoregressive conditional heteroscedasticity models, or ARCH, arch models. And the other family that evolves with a stochastic term, we typically refer to as stochastic volatility models. Stochastic, uncertain volatility, stochastic volatility models. Okay. So there are two families. In this class, we don't typically talk about stochastic volatility. We talk about arch models. Okay. So, but what exactly do we mean by an arch model? So the arch model, this is an arch one. Okay. This equation 2 here is an arch one. What is an arch model? It says that the variance of the error term, the variance of this term, the variance of this term, that is this one, is changing. But how is it changing? How does it evolve from time? We say it evolves according to this equation. In other words, that the variance at today's variance, current time, is equal to some constant, okay? And Danny, if you want to, you can say it's a drift, okay? But we don't normally use the word drift with the variance equation, but this is like a drift, the same terminology we use during the other models, and plus coefficient times the error squared lagged period 1. If this is the way the variance of the error term, what is this variance? This variance is this one of the error term, this one, okay? The variance of this error term. Without this t, it's homoscedastic. But with this t, it is heteroscedastic, it's changing. How does it change? We're saying if it changes as if the dynamics of the model, if the dynamics of the variance belongs to the family of deterministic models, arch models, okay, it could be arch 1, could be arch 2, could be arch 3, could be arch up to 50. But if it's this, exactly this one, equation 2 here, then we say it's arch 1. If it's this one, equation 3, if this one is arch 2. Why? Because we have two lagged error squared terms. Remember, this is the variance of the error term. This is the error term itself squared. Okay, so it's lagged 2 times. So this is arch 2. And then this is, if you generalize it, this is the arch Q. Okay, is the arch Q model. So this is the how we express it to be an arch model. So here equation 1 is the mean equation. That's the original equation. this one, it is concerning this equation that we make the assumption that the error term has average of 0, mean of 0. In this case, it's normally distributed, mean of 0, and heteroscedastic error term. So it is, whenever we make this assumption of mean 0 and heteroscedastic, we're attaching it originally to this mean equation. That's the original equation. Because if this variance is not changing with time, then we don't need arch models. We don't need stochastic volatility models. We don't need any model any model trying to find how the variance changes. That's why in Echo 4000, you didn't have to worry about arch and GARCH and stochastic volatility models, because we always assume that the variance of the error term was constant. So we didn't need to go into all of that in Echo 4000. We don't do that. It's just, we don't have time. So it is that equation for which we assume the error term is 0 and the variance is constant or not constant. That equation is called the mean equation. There's always a mean equation, because if there's no mean equation, then how can we worry about the variance of the error term from that equation, right? If there's no mean equations. Okay, so the mean equation is the first one here, and then the other equations are the arch equations. Okay, good. Now let me quickly go to the other one I showed you before the class before we run out on. So this is page 4. I showed you. I gave you page 1, 2, 3, 4. Okay, handwritten. So this is page 4. I want to show you this page quickly and then discuss pages 2 and 3. Page 4 says that the variance of the error term can also evolve in a different way. Again, this is the mean equation. We assume here the mean is 0. The error term we assume is normally distributed, the mean of 0, and changing variance. But here, look at the way the variance, we say the variance is changing. The variance at current term is equal to some constant or drift, quote unquote drift, plus the square, a constant times the square of the error term itself. This is on the left-hand side is the variance of, is the current value of the variance of the error term. Is related to the square of the error term itself. If I stop here, then that is the arch model. But then I introduce a constant times the variance of the error term lagged 1 period. This is what we call a GARCH 1-1. Okay, generalized arch. Generalized autoregressive, blah, blah, blah. Okay, so here the equation is the variance, current variance of the current value of the variance of the error term is related to the square of the error term itself lagged 1 period and the lagged value of the variance of the error term. So this is a GARCH 1-1. This is a GARCH 2-2 because it has 2 lagged values of the error term itself and 2 lagged values of the variance of the error term. Okay, this is GARCH 1-2. This is, I think this was the last thing I was saying on last Thursday. It is 2 here, right? Because the error term, we have 2 of the error terms. That's why it is 2. And we have 1 of the variance term lag. That's why it's 1. So this thing comes with P. So it is usually GARCH PQ, and the P refers to the autoregressive. We're regressing it on itself. So we're regressing the variance on itself. Only 1 lag period. That's why this is 1 lag. Okay. And because we're regressing on the 2 error terms, this is why it is 2. This just follows our ARMA PQ. Okay. All right. Okay. So let me go back to okay. But when you run an OLS, how do we normally determine whether the error term, how do we normally determine whether the error term behaves like we want it to behave? Usually, remember, many of you, you have told me in the past couple of weeks that we do residual analysis. Okay, now I want to show you quickly what you did in OLS in Echo 4000. This is going to be very quick. So if you have a question, please ask me. I'm going to do an OLS regression like you guys did in Echo 4000. I'm going to collect the residuals, and we're going to do a very quick analysis of the residuals. This is what you did in OLS in Echo 4000. If I teach Echo 4000, I normally do that. Your professors will usually do that for you. So let me just review it very quickly, okay? And if you remember it, that's fine. If you have questions, please ask me, okay? Let me do quickly here. Before the class started, I uploaded an Excel file. Let's see if I can find it. Okay, yeah. Okay, so this is a very simple Excel file. I think you guys can see it. It's telling me that you guys can see it. So I have 12 months of data, okay? I have a stock, Facebook machine. I don't know what I was thinking. FBM is a stock, okay? And then this is the S&P 500. So I want to run a simple characteristic line equation, blah, 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 simple equation. So I want to run a regression of this stock's return with this as an as the X variable, okay? So in other words, I want to run a regression that says something like this. Y equals A plus B, I'm sorry, not AA, not AA. Y equals A plus B times S&P 500, B times X, okay? Where X is the S&P 500 here, plus error term, okay? And then our assumption is that the errors will average out with constant variance, homoscedasticity, okay? So what I want to do is I want to run this a quick OLS equation, just like everybody here can do from coming from Echo 4000. So what do? I say data, okay? And so I clicked on top here. Let me go back. So this is the way the Excel program, you guys have done this before. I do data, okay? And I go to the extreme right-hand side here. You see data analysis. I click on data analysis and I bring up the drop-down menu, and I'm looking for regression because that's what I want to do. I do regression here. All right, I want to do regression. So let me erase all of this. Let me erase all of this. Let me erase all of this. Okay, let me erase all of this. Erase all of this. So I'm doing this from scratch. Okay. All right. So yeah, sorry. Okay. So what's my Y? I'm regressing the stock returns with the market return. So my Y is the stock. So I pick up the title because I want the title to show. So that is my Y variable. What's my X variable? I go and pick up my X variable. So this is my X variable. Okay. And I'm picking up the labels. I want the output to be somewhere here. I haven't shown where the output would be yet. Okay, so I want the output to be where? On A17. So I click A17 below. And then I want residuals, okay? So I want to collect the residuals. I don't want any fancy stuff. I just want to collect the residuals. Oh boy, I don't hear anybody. This class is so quiet. Are you guys out there?
We're here.
Okay, you're here, good. All right. Roxelana, are you still here, right?
Yeah, I'm here.
Okay, awesome. All right, so everybody, am I doing things okay? My Y variable is this is my Y. Stock return, my X is S&P 500. My output is here. I want to collect the receipt. Okay, so I say, okay. All right. It took, I didn't ask it for a residual plot, but this is like the QQ plot, this one. QQ plot for the residual, but let's not worry about that. So this is my OLS. So my OLS says that the equation is 1 point this. So the intercept is this, and this is the, what is this number again? 1.183?
The beta.
Okay, in ordinary coffee beer language?
That's the slope.
That's the slope. You're my man, Alec. Thank you. Okay, good. That's the slope. All right, so this is what I want to do. So I want to copy this. I want to copy this number, okay? Okay, let me go. I want to copy this number. Copy. All right, let me go back. I think I made it. Okay. So let me copy this number. All right. See what I want to do. I want to go up here and I want to say here equal to that number. What do I want to do now? Equal to, let me use absolute, right? Okay, sorry. Oh God, I'm so terrible in, okay, so let's make it negative 0.61029, okay? I don't want to mess around. So this is equal to parenthesis, negative 0.61029, okay? Plus, all right. Now I want to, what was the slope again? 1.1833403. Okay. Just watch what I'm doing. Plus 1.1833403 times this one. Okay. Can anybody tell me what I'm trying to do here?
You're trying to use.
I'm trying to use the equation the OLS gave us to plug into the plug S&P into it and see whether I get 12.05, the return. Is that right?
Yes.
Okay. I don't get 12.05, I get 13 points. So here we call it the predicted. You understand? That's what we call it in Echo 4000. We call it the predicted. Essentially, I have said, okay, that my equation is equal to, so my y, let's call it y hat equal to it's negative 0.61029 plus 1. What was it again? 1.1834, 1.183403 times x. So please, everyone, I'm just talking fast because I know you did it in Echo 4000. So we took these two columns, the stock return and the market return. We ran the OLS regression and we got the intercept, this one, negative 0.610 plus the slope. So I said, okay, that is usually an average number that we get. But using this intercept and using this slope, let us now go in and plug in the S&P 500 number for each month and see if we get this difference, if we get the exact return. I did not here. So let me copy this copy, and then you know, copy for the rest. So I'm copying the equation for the rest. When S&P is 5.99, I don't get that. I get 15 point this. When S&P is 2.41, I don't get this. I get different numbers. So what is the difference? The difference between those. What is it called? What is that difference called?
Residual.
That's the residual. Okay, that is the residual. So I say equal to is the residual is y minus y hat or y hat minus y. I don't remember. So let's do y minus y hat minus this. Okay, so let's do that. It's negative. So let me copy. Let me copy and let me extend that. I'm sorry, the way I do it is screwed. So that's what is supposed to be my residual. Okay, that's my residual. Now look at, okay, so this is my residual. Now, but when I ran the regression, I told Excel to give me the residual. So Excel gave me the predicted and Excel gave me the residual. Look at the predicted Excel gave me. Again, let me copy this predicted that Excel gave me. Let me copy the predicted that Excel
It's
gave me.
going to be slightly different, Professor, because
yes, because Excel goes to 12 decimal places, right?
Right.
Okay. So you do remember your Excel and your OLS. So I copy it and let me put it here. Okay, let me paste it here. I paste. It will be slightly different, of course. Okay, but look, 13.9219, 13.9219, 6.4 is 6.4, 2. You see that, right? It's almost similar. You see that? Okay, and then let me go and copy the residual that Excel gave me, and you see that the residual that Excel gave me is similar. It's similar. Let's, how do you do this? Let me go this way. Let me copy. Okay, so let me bring it up here. Let me bring it up here, and let me paste it here next to it. Okay, so I paste it here. That's the residual, okay? So my residual, who was it, Andrew or Alec that said it? Yes, it's different. This is negative 1.64. This is, okay? Because I truncated. I didn't use, here I use only 1, 2, 3, I use only 5 decimal places, but Excel is using all the decimal places up to 12 or something like that, okay? All right, so if I have convinced you that the residual Excel is giving us, that this is the way we obtain it. Okay, now let's go down to the residual that Excel gave us, this one. Okay, so let us analyze this residual. Let us determine the average value of the residual. Okay, so what have we done? What have we done? Step 1, we ran the OLS regression. Is that correct, everybody? Yes?
Yeah.
So we ran the equation using the mean model. We got the intercept and whatever, and slope. But here I'm not really interested in them, because what I'm interested in is I collect the residual. And once I collect the residual, I want to do the analysis of the residual. Let me see if the residual averages to 0. And I'm going to take, and then I'm going to calculate the variance of the residual, okay? All right, so here, let's do equal to here. So I want to do a function. I want to use average, okay? Average function. All right, and what am I averaging? I want to average the residuals here. Okay, so let me average the residuals. And I say average. Now, is this number 0 or not 0?
It's very, very small.
It is so
Statistically 0.
It is for all intents and purposes, it is 0. times 10 to the negative. So this is minus 5.18104 divided by 10 to the power of 16. Remember, 100 is 10 to the power of 2. So I'm dividing this by 10 to the power of 16. That is as close to 0 as you can get, okay? Now, if I want to calculate the variance of this, what do I do? Okay, now I'm going to use the equation, but how do we calculate the variance? I come to this residual, I subtract from it the mean. Is that right, everybody? Remember? And I square it, right?
Yes.
Now, because this is close to 0, if I subtract this thing from each of them and square, it's practically like I'm subtracting 0 from each one and squaring. Is that correct?
Yes.
But instead of just subtracting 0 from each one, if I just go here and square each residual, then my result will be the same as if from each residual, I'm subtracting 0 and squaring it. You understand?
Mm-hmm.
No, only one person is answering. So everybody look, if I want to calculate the variance of this, I come in here, right? I say this is equal to this minus the mean here. Is that right? But if the mean is, and then I square. So I do this and I square. And I come here, I do it, I square. I come here, I use this, I subtract the mean, which is practically 0, and I square. So why go through those annoying steps? Because the mean is already very close to 0, it's practically 0. What do I really need to do if I need to calculate variance? I just square each residual. Are you with me?
Yep.
Am I allowed to do that? Yes, I'm allowed to do that because the mean that I'm subtracting the mean from each one, the mean is practically 0. So I don't want to waste my time. I wanted to say my freaking time. But as professor, I cannot say it. So please forgive me. Okay? All right. So essentially the way to calculate the variance of the residual, because the mean of the residual is practically 0, the way to calculate the variance of the residual is square each residual, add them up, in this case, divide by 12. Okay, that would be the variance. Okay, but but we already have the equation for variance. We have the formula. So I'm going to say calculate for me the variance. So I'm using the formula variance of the population in this case. I'm assuming it's population. And what is the, so I tell it the numbers to use. And then it calculates for me the variance. And so the mean is, this mean doesn't look to be 0, it's very small. This variance doesn't look to be constant, okay? But then with these two numbers, I can then go test the hypothesis, whether the mean is 0 and the variance is constant at that number. And then I either accept the null or either fail to reject the null or reject the null. This is what you did in Echo 4000, okay? Residual analysis, okay, very nice. So just come with me with the same idea. So how do we test for arch effects? Okay. Again, this is page 2 of the 4 handwritten page handout you have. How do you test for arch effect? All right. Wait, are you guys looking at this?
Yes, we can see it.
You can see on top here, test for arch effects, right?
Yes.
Okay, good. Let me close. Do you want to? No, I don't want to save the changes. Okay. Let me actually do better. Oh, screen. Okay, it has stopped. Yes, I stopped sharing the screen. Okay, sorry. I just want to go back to to a screen that I'm familiar with. I had to close the Excel page. All right, so you guys can see this now. No, this is page 1. Let me stop sharing. Let me go back to page 2. Please bear with me. I'm just messing around here. Where is my page 2? No, I am now messing up. Sorry, guys, I kind of lost my bearing here. All right, let me go and just bear with me a second, okay? I lost my position here. Let me go and bring this up. Okay, so I'm bringing up page 2. All right, I do this and I'm bringing up page 3. Sorry, guys, I must have accidentally closed those 2 things. Okay, so let me go back now and do them again. Okay. All right, sorry about that. I think I accidentally closed it earlier on. So this is how we test for arch effect, okay? So I specify a mean model. So the step 1, whatever your mean equation is, whatever the equation you are using as your mean, it could be the simple market model that I used as in my Excel spreadsheet, or it could be autoregressive model. It could be moving average, it could be autoregressive model of order 1, of order 2, whatever the mean model is. Remember, our assumption is usually that the error term is well behaved. In this sense, it could be white noise with 0 mean and homoscedastic. But at the end, when we run that mean equation, we want to test whether the error term is behaved. In this particular case, we're interested in seeing whether the variance is constant or not constant. Okay, so that is what we mean by testing for arch effect. So we run this model here you're looking at, and we collect and we save the residuals, just like I did for the Excel spreadsheet. Okay, now we collect the residuals, and what do we do next? Can you guys see this? I don't think it's big enough. Okay, so we collect the residuals. So we run this module, we collect and we save the residuals. What is the second step we do? Can you guys
square them?
Okay, why are we squaring them?
To find the variance.
To find the variance. But why square only the residual? Why don't I say each residual minus
0?
Thank you. Okay, thank you. Because the average of the residuals is 0. So that's why we square the residuals, okay? All right, so that if you guys are reading this anywhere, and if you're reading this anywhere and you see, what the heck did I just do? Oh my goodness.
We can still see the worksheet, Professor.
Oh, you can still see you can still see my handwritten note?
Oh, not anymore.
Okay.
It just disappeared.
Sorry, when I get excited, I just tend to just move things around. Sorry about that. Okay. So you collect and save and then you square the residuals, right? Now, in the spreadsheet and in Echo 4000, that's where you stop. You analyze the mean of the residuals, and then you analyze you look at the residuals. Okay, but here, because we are testing specifically for the arch effect, we want to see whether the variance of that error term. Remember, by squaring the residuals, we are essentially wanting to calculate the variance. But so we want to see whether the square residual changes with the lag values of the residuals themselves. The squared values of the residual, not the variance, I'm sorry. We want to see whether the squared residual current changes with, that is determined, is explained by the lag values of the residuals. This is really a proxy for the variance, current value. Remember, because up here we are squaring the residuals. but really we should be squaring minus the mean squared, okay? So we want to run this equation. So the squared residuals we got, so we put it on the left-hand side as a y variable, and then we regress it against its lagged values, the lagged values of this. Guys, if there is no arch effect, I don't need to go further. If there's no arch effect, what will my coefficients be? This gamma 1, gamma 2, gamma 3, and gamma q. What will the coefficients be if there's no arch effect?
Homoscedastic?
Yes, if it's homoscedastic, what will this gamma 1, gamma 2, gamma 3, what should they be?
0.
Of course, they should be 0. Because if they are 0, it means that the squared residuals at every time does not depend on previous squared residuals. If that is the case, then there is no arch effect. So what do you think would be the null hypothesis of this test?
Professor, can you please repeat the last part one more time, please?
Okay, which part?
Where there's no arch effect.
Okay, excellent. Okay. Now, are you looking at this equation here?
Yes.
Okay. What happens if gamma 1 is 0, gamma 2 is 0, and then up to gamma q? If all these gammas are 0, gamma 1 to gamma q, if they are 0, what happens? Then none of these items is relevant to the equation. Is that right? Who asked me that question?
Yes, Sophia.
Sophia, okay. So if gamma 1 is 0, then this whole term disappears, right? This whole term disappears. If gamma 2 is 0, so if gamma 1, gamma 2 up to gamma q, if they are all zeros, Sophia, that means everything here beginning from gamma 1, everything here is 0. That means that the squared residual is not determined by any of this. Is that correct? It's not determined by any of this.
Yes.
So when it's not determined by any of that, we say that the variance is not changing, that the variance depends only on this one, right? And on average, again, I shouldn't really introduce this, but on average, this thing disappears. But if the variance does not depend on any of these items, the variance is constant. So it's either that the variance is constant or the variance is not constant, but is changing according to this equation. And therefore, if it's changing according to this equation, then we say there is arch effect. Okay? All right. I can explain it some more, but let me move on because I want to run through this. Now let me go to page 3. Okay, so I continue on page 3. Again, you have all these pages 1 through 4. This is page 3. So the fourth step is after running that previous equation, we say we determine a test statistic. Okay, that test statistic is T times R squared. So from that equation, we get the R squared of that equation, and then we multiply it by time, by the number of observations. Because, let me go back. Sorry. Somebody talk to me. If gamma 1, gamma 2, gamma 3, and all of this, if they are really 0, but I run this regression, what will my R squared be? My R squared should be very small. Is that correct? My R squared should tell me that none of these things, all of them, none of them individually and collectively, none of them determines the left-hand side.
Correct.
So if I run this equation using OLS, we run it using OLS, and the R squared is 0. What does it mean? If the R squared is 0, when I run this OLS regression, what am I saying?
The variables aren't really good at explaining the outcome.
Exactly. So these variables, this one, the lag square errors are totally useless in explaining this one, the current value of the X. So when you run this regression, you collect the R squared or the adjusted R squared, whatever R squared is relevant, whether it's single or multiple. Okay, so and then you multiply the R squared by the time t. Okay, you multiply the R squared by the t. Sorry, I made a mistake. Okay, so you multiply the R squared by the number of observations, and then this R squared multiplied by the number of observations should follow a chi-squared distribution. But typically, all you do when you do this test, you look at the p-value. And the p-value, if it's very small, less than 0.05 at the 5% level of significance, we say we reject the null. If the p-value is smaller than 0.05, we reject the null. If the p-value is larger than 0.05, we say we fail to reject the null. But what is the null hypothesis? This is important. Okay, for the final exam, you guys have to remember this. What is the null hypothesis? The null hypothesis is that, oh, not talking to me. The null hypothesis is that all the gammas are individually and collectively 0. Okay, that this equal to 0, gamma 1 is 0, gamma 2 is 0. That is, gamma 1 is 0, and gamma 2 is 0, and gamma 3 is 0, and gamma 4 is 0, and gamma q is 0, and all of them are equal to each other, just like for the portmanteau test. Okay, and the alternative is at least one of them is not 0. So you look at the p-value. Okay, everybody? All right. So again, let me show you one final time, and then I'll go to the R. Okay, so we square the residuals. So in doing the test, we collect the residual, we square them, and then we run, actually using OLS, we run this equation. And we want to test whether this is 0, gamma 1 is 0, this is 0, gamma 2 is 0, this is 0, all of them, each of them is 0, and all of them are equal to each other, equal to 0. They are individually and jointly equal to 0. Because if we accept that premise, if we accept that statement, that each of them individually and collectively is 0, then we are saying that there is no arch effect. In other words, that our error does not follow the arch effect, the arch model. Okay.
Professor?
Yep, Danny?
So the error term is static in this case, right?
Yes, this error term, this is, okay, here. This error term, right? No, sorry. The regression I just showed you, yes?
Yeah.
Okay, so this error term, this one is just like, you remember when you run OLS, at the beginning, you put an error term, but you are really saying that error term disappears, right?
Yeah.
So if there's an arch effect, we're saying that this is equal to all of this without the error term. Remember, when you do OLS, you start by specifying the equation with the error term. But by running OLS, you are running the expected value of the y variable. So remember, when you run OLS and you want to write the equation of the OLS, you don't usually include the error term. Remember that? You don't remember that? Okay, let me show you now. Let me just show you what I did that just automatically.
Yeah, I got it. I thought I pressed unmute.
Okay. Okay. Remember, when you run OLS and you collect the intercept and the slope, and you want to write the predicted equation, you don't include the error term. You just write the intercept and the slope. That's all you write. Okay. All right.
Correct.
Yes, Roxolana, if you accept the null, then there are no arch effect. Yes, but don't take my word for it. Okay, don't take my word for it. Just look at it. Let's look at it. All right, let's look at it here. Roxolana and everybody else. If there is no arch effect, that means gamma 1 equal to 0, gamma 2 equal to 0, and all the gammas are individually and collectively 0. if all of them, that is what we specify as our null hypothesis. And if there is no arch effect, then we have to accept the null or fail to reject the null. Okay. All right. So let's do a quick R example. Okay. Let's do a very quick R example. I hope this works. Before the class, I ran through it myself just to make sure it will work. Okay, so this is the R. This is my R. Let me go back. You know, it's just a lot. I didn't want to go back and rerun everything from beginning. What did I just do? Let's see.
You don't have any scripts open, Professor. This is just the results.
Yes, I want to. That's because something is blocking. Let me stop sharing. Okay. Let me go back to my Excel equation and try to fix that. No, I'm sorry. Let me go back to my. Okay, I think I know what happened here. I am being blocked by the screen. Let's see. Let me see if I can move this down a little bit. It's right here. Oh, God. I don't have the, how do I get it back? That's what I'm, I need to click on.
File, open recent.
File.
Open recent files.
I'm sorry. Yes. Sorry. File. Yes, I actually have it, but it's, you know, when I'm sharing your screen in this thing here, the message that tells me that I'm sharing the screen is blocking. I need to click on the, you know, the two squares so it comes out. So let me get the recent, but I don't want to rerun it. So I'm guessing that okay, let's see. No, it gives me something else. Okay. Just hold on, okay? Just give me a second. I know exactly what I want to do. So let me bring up the R equation, and no, and save. Okay, look, if I run into trouble, too much trouble, I will just paste for you the, okay, I have it right here. I paste for you the, okay. Okay, I see what I do. Let me minimize it. Okay, so let me minimize it. If I run out of time, I will, which was what I was going to do anyway over the weekend, I will post the comment and then you guys run it yourself. It's just one line, okay? Okay, here you go. All right, everybody see this, right?
Yes.
Okay, sorry about that. I had my screen maximized. So my zoom command on top was blocking. You see this here, I wanted to screen this, but the zoom thing was blocking it. And if I clicked on it, I'll end the zoom session. I didn't want to do that. Okay, so look, this again, I'm going to post all of this for you. I didn't want to do it over the weekend because you guys were busy. So look, these are the commands. Everything from line 1 to 7, we already did before in this class, okay? This is I set working directory to my R folder. I pick up, you know, that macro data variable, CSV, I pick it up. I make it a time series, blah, blah, blah. I've done all of this. And then I extract the GDP, remember? And then I extract it, put it in Y, and I plot Y. That's here at the bottom right-hand side, I have plotted y. So I have run this before class. Okay. Then I went on to install all these packages. Okay. T-Series, Zoo, you guys are already familiar with it. FINTS, you're already time series, financial time series. I think I've used this in class before. The new one you guys are not using is GARCH. Okay. So, but actually within financial time series is a lot of what we want to do here. Okay. All right. So I'm going to post all of this for you. So I install all of them and I library all of them. I bring them in. All right. I have run this before, but let me run it again. Okay, everyone? Somebody is chatting with me here. If we accept the null, then there are no GARCH effects. Yes. Okay. I think that was the old chat, Roxolana. Okay, so I plot my time series of y, the GDP. This is the time series. So at the bottom right-hand corner here is the GDP. So look, everybody, are you looking at line 28?
Yes.
Line 28, bottom line is what I explained to you on page 2 and 3. So I'm going to test for the arch. So what does it do? It will run the equation with a mean equation. And I'll show you this, what the mean equation is. And then it will collect the residual. It will run residual. It will collect the residual, square it, and run the test equation, and then determine whether the gammas are 0. That's what it's going to do with this one line. Isn't that neat? So this one line, we do the arch test. Okay. Actually, let me back up. Let me plot y again, just to give myself space. I plot y, I run it. Okay, so here it has plotted it. Okay, so let me now do the arch test. So I do the arch, sorry. I do the arch test. Does it give me a result? Let's see. It should give me a result. Why am I not seeing the result? Let's see. Okay. The result is okay. Sorry, it's just wasting time. All right. Okay, guys, you know, I did it before. Let me just, I don't know what's going on here. Let me show you the result, okay? And I'll post it, and then you guys run it yourself. I have run it before. Let me show you the results because I want to explain. Okay, here, guys. So this is, if you do the arch test, if you do that command, arch test, this one, and you type it, this is the result it gives you. So I do the arch test, and it gives me this result, okay? So this result says arch Lagrange multiplier test, okay? Null hypothesis, Roxolana, you see that? Null hypothesis is what? No arch effects. You see that?
Yep.
Okay, and then it gives me my chi-squared, degree of freedom 12. My p, look at my p-value. So tell me, according to this p-value, should I fail to reject the null or should I reject the null?
Reject.
So if I reject the null, what am I saying?
There are arch effects.
There are arch effects, okay? Everybody understands this, correct?
So
Yes?
that's the conclusion, Professor? There are arch effects?
Yes, that's the conclusion. There are arch effects.
And that there's dynamics for the variance of the error term?
Yes, but exactly what is the dynamics? I follow this up. Okay, exactly what is the dynamics? I'm asking it to run a Gauche model for me. You understand? Okay, so let me run this. I already did it. So let me not waste time. I already did it, so let me go down here. I ran it. You see? I ran it earlier on. Okay, I ran the GARCH and I told it to give me the output. So look, I ran this equation on line 29. Everybody see that? I ran it and then on line 32, I said, give me the output of this Gauche model. So this is the output here. Let me quickly explain this. Okay, let me explain this for you. Just the output is a lot, but let me just quickly point out some things. So look, the Gauche model fit. All right, here. This Gauche model is the standard Gauche 1-1 equation. Okay, this little s means standard Gauche. Remember, I showed you on page 4 of my handwritten note, I showed you the standard Gauche. And then what is the mean model? Can anybody tell me what is this mean model? AFIMA 101. This is really autoregressive moving average, ARMA 1-1. You see that? Because the I is 0. Everybody
Yes.
see? Okay.
Yes.
So this is the default setting for this package, and the distribution is normal. So I'm saying run the ARMA 1-1 as a mean model, and tell me whether the residual of that equation is homoscedastic or not. Okay, and we found through the ARCH test that it is not homoscedastic. Danny, we reject the null, meaning there is ARCH effect. But I'm telling it to run the Gauche model, and let me see how the Gauche model, how good the Gauche model is. Okay, so the Gauche model says here, these are the parameters. Mu is a constant in the mean equation, in the ARMA equation. This is the AR1 coefficient. That's the phi. This is the theta, the moving average equation. Those are the coefficients, okay? And these are their p-values. This is the constant in the Gauche equation. Remember, variance squared t equals constant plus the alpha. Alpha is the error squared equation. So here is 0.000. So this is all 0. And then the beta is the coefficient for the lagged variance squared equation on the Gauche equation. So this is the coefficient, okay? So obviously this coefficient, this model is not good for my GDP data, but I just wanted to run it to show you, okay, how it's done.
Professor,
okay. Yes.
Where does it show it's not good? Where's the?
Well, I'm just saying, look at the p-values, they are large. The p-values are large for the coefficient of the, okay. This mu, AR1 and MA1, they are the coefficients of the mean equation, right?
Yeah, the autoregressive and moving average, right?
Yes, those are the coefficients. And then this, the omega is a constant in the variance equation. Alpha is the coefficient of the error squared term, lagged error squared term, and then beta is the coefficient of the lagged variance term, okay?
So the last three is where the dynamics of the variance is, right?
Yes.
You have to look at those three.
Yes.
Okay, omega is the drift from earlier, right?
Omega is the drift, that's correct.
Got it.
Okay, and I mean, this model is no good because the p-values are no good, because I'm just for the GDP model, actually it's fractionally integrated. I did it some time ago, but so this Gauche 1-1 model is not good for it, but I don't care about that for now. I just wanted to show you how to run it, okay? So for the project, all you need for the project so far is line 28, the ARCH test. This is the equation you need. This is the command you need, okay? All right. So I'm sorry I ran over time. I mean, these things, usually when I do R in class, sometimes it gives me a lot of errors. That's why I like to do it before class. Okay. So let me stop recording.
The recording has stopped.
Okay, so the class has ended. So if you have to leave, you can leave. If you are two members of a group and one member has to leave, that member can leave, but the other member can stay and ask me questions. So between now and 7:30, I'm just going to take questions on the project. On Thursday, 2 days from now, the class, I will just come, maybe in the first 10, 15, 20 minutes, I will present other other arch models, exponential GARCH, leverage. There are so many other arch models. I will just present them to you, take 5 minutes each, explain each one, and then I'll stop teaching class. And then we shall just work on the project. So between now and Thursday, I beg you, everybody, every team, begin your project and then bring questions to class on Thursday, okay? All right, so from now, officially it is 7:30, I'm available to take questions on projects. If you haven't done anything and you have something else more important to do, just leave the class, that's fine. The class is ended, everybody, okay? But if you have questions, I'll take the questions up to 7:30. Professor, this is unrelated to the group project, but I have yet to receive my, guys, okay, please, can you stop sending me emails about your grades, especially in the homework 1, homework 2, homework 3 that you just redid and you resubmitted. Many of you submitted, you redid homework 1 and 2. When did you submit it? Midnight Sunday. Today is Tuesday. We are still grading them. So just stop sending.
Professor,
Hold on. Please stop sending me emails about your homework grade. Just keep checking. Tomorrow morning, check. You'll probably see homework 1, redo, the grades posted. Me and the TA, we are working very hard. We are busy doing other things, but the deadline was Sunday. Okay, so we are grading. As soon as we finish, we post. As soon as we finish, we post. So you have to trust me that we are working hard on grading those homework. It was due on Sunday, this past Sunday, midnight. So Monday, we began to grade, Monday afternoon. So we are grading. But some of you keep sending me emails. Don't send me emails. Trust me, I'm working on your grades. Okay, all right. Yes, Danny? Somebody was asking me a
Professor,
question.
I have a question.
Wait, was Danny or Andrew? Andrew, you had the question first.
Yeah, the question first. So can we resubmit? I didn't realize we were resubmitting homework 1.
No more. No. I think I sent enough emails already. I sent the email early last week.
Okay, no problem.
Yeah, it's just fine. Confusing. Okay. Look, you guys will do well without that homework, but now we want to move past homework. I want to focus on the project, okay? Just let's focus on the project, do as well as you can, and your grade won't suffer at all. Homework 1 will not affect your grade. All right, Danny?
Professor, for the conclusion for the box peers and Leon box, is it safe to say that there's no serial correlation within the lags jointly and individually?
Look, for the project, I want you to use technical language, but at the end, also use simple layman's language. Because many of you, in your attempt to use sophisticated technical language, you get it wrong. That's what concerns me. So you can say, yes, you failed to reject the null hypothesis. The null hypothesis is no serial correlation, or whatever the null hypothesis is. So you can say, fail to reject the null hypothesis of, then you state the null hypothesis, okay? Then you have to say, that means that, then you need to use the ordinary language. Because I really don't trust some of you to use technical language. Not that I don't trust some of you. You tend to use technical language and then you get it wrong in the technical language. But when you guys talk to me in class or after class and you talk to me with simple language, 100% you are always right. So that's why I want to insist you go back to your understanding. So use the technical language. Yes, according to the p-value, we reject the null. The null says this. So we are rejecting that. That means there is no serial correlation. Okay. What does that mean in plain language? I want to see that. Okay. All right.
Professor?
Yes. Who? Tobias. Yes.
Tobias, how are you? Good evening. How is
Hey,
everything?
hi, buddy.
Good. So I have a question. Like, it's pretty rudimentary. So me and Ali, we were trying to work on our assignment last night, and since the homeworks we were doing, we were using it from Google. We were having a little bit of issues calculating the logarithmic returns. Like using R, we couldn't really find the code to do that.
Okay, hold on. Hold on. Just hold on 1 second.
I know it's pretty rudimentary, but
hey, just stop saying that. Okay, there's nothing that is rudimentary in this class. Believe me, sometimes I struggle with that too. Look, to calculate the log return, you see, are you looking at this?
Yeah.
Okay, look at line.
I did a code that
look at line 5, right?
Yeah.
Okay, so in your textbook, I put the pages here. In your textbook, it says use natural log of PT this one, okay? And in fact, the way your textbook mentioned this is diff, I think is diff log.
Okay, I'll go back into those pages.
Now go back, Tobias, hold on. Go back and check it because we did it for homework 1. But if you don't find it, Tobias,
yeah.
I mean, again, trust me, try and find it, you and your team members. But if you don't find it, don't just stay there and cuss Onochi out, okay? Send me an email, okay?
Okay, yeah.
If you send me an email, then I will show you the specific command on that page.
All right, thank you so much.
Okay. Again, if you don't get it,
we'll figure it out. We'll try our best.
Okay, but contact me.
Sounds good. Have a good evening.
Awesome. Andrew, you're clapping for me. Why?
Hey, I have a question.
Okay.
So can we use any stock? It wasn't really that clear. We can, right?
No. Hey, look at the first line of this project.
Raw data prices.
Use the raw data price level. What did I underline?
Assigned to your team.
Yes.
Gotcha.
Are we getting an email on exactly what stock we should be analyzing?
What are you talking about?
There was data sent to us, like the.
I mean, I sent data to each team on Saturday. I mean,
or on to our emails. Maybe I just overlooked this, but I'm sure I'm not the only one in the class that.
No. Don't tell me you're not the only. If all of you overlooked it, all of you get a 0.
That's
because,
what.
Hold on, no. Not all of you overlooked it because many of you came back to me. I insisted that you come back to me with your email telling me, again, between now and the end of this semester, I want you to please read instructions. I sent to each team an email to both team members, and I sent the data for you to use. And at the end, what did I say? I say, reply to me confirming receipt. Excuse me, can anyone here now listening to me, can anyone verify that I did that? Did you get that?
I received the email.
You received the email, and many of you, you came back to me, you confirmed that you received the email with attachment. All right, so who's asking me this question? Is it Lily or is it Roxolana?
It was Lily. Me and Andrew were both in a group together, so I was curious because it said assigned to your team, so I was like,
wait. You and who are in the same team?
Me and Andrew. So that what was.
Wait. Andrew and Lily are in the same team, or Andrew and Roxolana?
Andrew and Lily.
Andrew and Lily are in the same team. I sent both of you your data. I sent you an email.
I found it in my spam folder.
Okay. So and
I had to clarify this before submitting the project.
Okay, wait, hold on. Andrew, did you get it?
Yeah. So I actually gave you my actual personal email, and it's in my spam folder. I just checked.
Okay.
Sorry. That's why I wanted to stay before class to ask you and clarify this question.
Okay, I sent you all emails using the email address you have on Blackboard. Everybody in class. This is very important. Thank you, Andrew, for asking me that question. That's very important. You don't use any stock. Please use the exact data I sent you. Okay, Lily?
Got it.
Thank you,
Glad
Professor.
to clarify that.
Okay.
Thank you.
All right. Have a good evening. But you don't need to go. I'm still here. Okay. And I'll be here till 7:45 if you all need me. Okay. I'm sorry, I was a little panicked now, because if Lily is asking me that question, that means there's some trouble. Okay. So excuse my, again, I was, all right. So I sent it to everybody in class. So Lily and Andrew, please reply to me and confirm that you received the data. Okay?
Okay, thank you, Professor.
Awesome. All right, any more questions, anybody?
Professor?
I am here till 7:45, yes.
Yes. So I actually, yeah, I just finished like the most of the coding, and the ARC test that you just talked about, I actually using like the coding in the book. I managed to like find what's like their source ARC text, and I use the coding in there. Or
Okay.
is it, should I just like change back into what we did today?
No, that's fine. You probably found the equation from the author, is that right?
Yes.
Okay, that's fine. If you can do that, that's fine. And if you can interpret that, that's also fine. Okay.
Okay. Thank you.
Okay, but it's just that the package I'm using is much simpler to interpret, but that's okay. That's fine. Okay, Mr. Lin?
Yes. Yeah.
Okay.
Yeah. I'll check again. I
Okay.
guess.
Have you run through all the commands so far?
Yes. I pretty much finished all. Yeah, I finished all of them.
Okay. So if you have questions, ask me on Thursday, but please continue working. Okay. That's great.
Yeah. Thank you.
Awesome. You see, so this is not difficult. It's just long because I'm giving you step by step, but this is essentially homework 1, 2, and 3.
Professor,
Yes.
I just want to make sure we're just writing the null. We don't have to write the hypotheses, right?
No, I would write the null and the alternative. That's a good habit.
Okay, because it just states the null.
Yes, I can ask you everything. Okay. I mean, if I keep asking you to state the alternative for every line, every command, then I'm just adding a lot more. Again, I always prefer to see the null and the alternative. That's a good habit. But if you have to show me only one line, then show me the null. Okay, Danny? Who asked me that question? Danny?
Yeah, that was me. So
Okay.
plus the null. I just want to make sure because it states just the null. So I just want to make sure there's no
Look. Again, we're not machines. If you have to give me only one thing, give me the null. But if you tell me that you're rejecting the null in favor of the alternative, what is the, okay, you know what? I'm going to go back to the homework problem, and I'm going to, everywhere I said the null, I'm going to include the alternative. Would that be better for you, Danny?
Yeah, I just wanted to clarify that.
Okay, all right, good. All right, but if you must give me only one, give me the null. But if you